This morning I talked to the head of your chemistry department, and they both shook my hand. They both, they both tried to find flaws in my thing. Your physicist told me I wasn't going to cheat the second law of thermodynamics, which is their golden rule that, the conservation of energy. And I'm not trying to cheat. I've cheated. But this is my solution.
Solution to what?
To renewable energy. The renewable energy problem, especially foreign oil.
All right.
Because we're dying for foreign oil. If we don't solve this foreign oil problem, your children are going to be asked to go give their lives for some more foreign oil. Yeah. And that's a fact. I don't have to be a prophet to tell you that. So what I've done is basically three containers. Okay, these are sealed.
What are they made of?
They can be made out of anything that will hold up to 150 degrees. This is going to be a catalytic reaction that the temperature of the reaction is 150 degrees. And I've made this in Colorado, and I have one at the Peace House that I kind of could have brought here, but making hydrogen in the classroom, you still kind of want to make sure. Yeah, I mean, like I talked to your professors, and you'll find out that hydrogen is a lot safer than we've been taught to believe. And so okay, this will go back here.
Isn't hydrogen what they make bombs out of?
Yeah, in the beginning you can. Okay, this is the reservoir. And what's in this reservoir is a sodium hydroxide. NaOH. Sodium hydroxide is a salt is sodium chloride. If you take the chlorine out of salt, you get sodium. And if you mix it with water, you get sodium hydroxide. Well, this is a sodium hydroxide solution. And what happens when you put the solution in a container like this, it'll level out by itself, right? On the shelf here, I have aluminum, and it's just sitting on a shelf where the solution can get to it. This is a bubbler. And this is going to a vacuum pump. And out of the vacuum pump is going to work. We'll say a generator. Okay. Now what happens is, when I turn my vacuum pump on, it pulls the sodium hydroxide up to the aluminum. The aluminum sequesters the oxygen from the solution, freeing hydrogen. The hydrogen comes over here, is free, and the whole system is under negative pressure. They have all types of motors that are ready to run on hydrogen right now. It's the fuel of the future. It is super clean. All fuels are actually hydrocarbons. And the problem is the carbon. If we take the carbon out of our fuels that we have, the pollution goes away. We don't have to, we can just get it from water. And instead of like having to destroy our oceans, digging the oil and all the trouble we're having with foreign oil. We're destroying our planet, we're destroying our children's future and our children for this one thing.
Plus the spills.
Plus the spills, and I mean, there's spills on land too. They're working in wind.
So what? Are you the first person to think of this?
Well, apparently the first person that's really taking it serious. You know what I mean? I spent a year of my life experimenting, doing every possible type of experiment that I could do to create hydrogen in a safe manner.
Yeah.
And in a safe manner, I mean, they make it through steam refitting is the most common way. and they do it through electrolysis. The hydrogen highway in California uses the sun to make electrolysis, but then they store it, and they store it under pressure, and that's the problem, is the storage under pressure makes it dangerous.
And you went to the physics department this morning?
Yesterday. I went to chemistry department this morning.
Oh, you went to both?
Yeah.
And told them about this?
And told him, drew it out, showed it to him.
And who did you talk to?
The head of the chemistry department, his name is Dr. Gerard.
And he came out and spoke to you?
Yes. We sat down at his desk and I showed him everything. He made me sign my work. He shook my hand. And all kinds of good stuff. The physics, like I told you, the physics guy said, you're not going to break the second law of thermodynamics. That's all he wanted to say. But besides that, he didn't have any other negative thing to say.
So what was the second part? The one that was receptive to you?
Yeah, is the head of the chemistry department, Dr. Gerard.
Then what building?
Bigley? Bigley,
Does
room
anybody take
104.
physics? Does anybody know Steve?
Bigley?
Huh?
It's in the back.
Oh,
Yeah.
McKinley?
No, it's
No.
by like the fields.
Oh, yeah, okay. So you spoke to the chairman of the department?
Yes, the head guy. Yeah, he was a pretty impressive guy, and he seemed pretty impressed with me because he had this humbled look on his face, and he shook my hand. And look at this as a real simple solution. The first one I made for like $10 because I'm a forager. I don't really work for money. I don't have a lot of money.
Right.
I play guitar. Sometimes people give me money, but I can't. I don't have a science lab like Tesla did.
So what did he say to you?
He said he thanked me, and well, one thing it was respectful because I told him I was going to show this in your class today, and I didn't want, in case one of his students happened to be in this class and went back and talked to him about it, I didn't want him to be in the dark.
Right.
It was just politeness, manners, and I was kind of wanting feedback.
Yeah.
Especially opposition, because it makes me stronger.
Sure.
Or it makes me, in case I missed something. But I've gone through this so much, and the one I made was supposed to be a mole-an-hour reaction. A mole is the atomic weight times a gram.
All right.
So a mole of aluminum is 28 grams.
Yeah.
And I was going to burn 28 grams in an hour to produce my thing, but I didn't have to do that. A pound of aluminum is $1 for used aluminum. That's the going rate.
Yeah.
That's the international market rate. A pound of sodium hydroxy is $1. But the sodium hydroxy stays in here, so this only requires $1 worth of fuel.
Yeah.
You may or may not have to buy, because we throw aluminum away. You can get a pound of aluminum walking down the street practically. You know what I mean?
Yeah.
This pound of aluminum ran for 3 days at a perfect thing. When the solution came up and hit the aluminum, it made just a line right here, just a foam. And that was the reaction happening. And the hydrogen was being free, come over here. The vacuum, when I first made this, I made my liquids up here so that the aluminum, the reaction had to push the solution away, as in a Kipps apparatus, which is an 1800s version of this. And, but my hydrogen had sodium in it, making my flame yellow, and so I knew I wasn't getting a pure product. But when I added the vacuum to it, the hydrogen being the lightest element, and you know how vacuum cleaners pick up the lightest thing out of the carpet first, it just picked my hydrogen up perfectly, and it was pure hydrogen, pure clean, without all the sodium in the solution. The sodium's my catalyst, which gets used over and over again.
Steve, can I ask you a question?
Yes.
So for your $1 of aluminum you had in there, how much hydrogen did you end up with? And how much, would that translate into, a car?
It was
or
enough to
motorcycle?
run a small generator that you can get at Home Depot for $200 for 3 days.
The generator ran for 3 days.